chapter 6, 1, day 1.
Chapter 6, section 1.
So 6-1, day 1. Chapter 6, section 1, day 1.
That sounds so awkward.
Yeah. Okay, so here's how it's going to be. On the first thing that you're going to be doing is we're going to be looking at what we call exponential things. Exponential meaning, if you think of the core word of exponential, what word that you've heard in your life before does it sound like?
Exponent.
Right. It sounds like exponent. So, Nevaeh, give me a number. 7. The first couple problems are going to be something like this, where it says 7 to the x. And then it will go on to say like x equals 2 and x equals negative 3. And the directions for the first 3 problems on your assignment are going to say evaluate, which means plug in the numbers and let's see what we get. Okay? Now, what people do wrong is when they plug that in, they do not put 7 times 2 rather than 7 squared, because that's what they're asking you to do. Now, which thing is the variable up there? Is it the 7? Or which thing is the exponent? Sorry. Is the 7 or the x?
Yes.
Good. With these, you will notice that the exponent is where the variable is at. Okay? So on the first one, you're going to take 7 and square it. What's 7 squared? 49. Nice and easy, right? And then when you type this one in, 7 to the negative third. Is everybody clear and comfortable with how you type this in your calculator?
Yes.
7, the caret symbol. Which one's the caret symbol? Look, button right below the clear. Okay. Now, some of you will have a decimal in this case, where if you do that, that's fine. But in case you wanted to know, there's another way of attacking it. If you forgot, which you might have forgot. To get rid of negative exponents, if it's on the top, you bring them to the bottom, and it becomes 1 over 7 to the third. And then if I were to know what 7 to the third is, which I think it's 343, I end up with 1 over 343. Now, I heard and overheard someone say a decimal to me, like point blah, 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 blah. Now, if you use your graphing calculator and you type 7 caret negative 3, you will get the decimal. But if you didn't remember this on your calculator, you can turn a decimal into a fraction. You hit the math button.
Oh, not that. Shoot.
After the decimal is up, you hit the math button, and it's the very first option, and you would hit enter twice. So you're fracking it.
Oh, I got it.
So now I will get the same answer that way as I would normally. I will take either way.
Oh, I was wondering.
I love my fraction
Yeah.
button.
Okay, are you guys comfortable with the first 3 questions of your assignment? Okay. Now, after that, it's going to ask you knowing the difference between growth and decay. What does it mean when I say the word growth? What do you think? Increase, move up. I saw a lot of thumbs going like this. Okay. What about decay?
Go down.
Go down, get smaller? Okay, now, what they're going to ask you for on this part of the assignment is they're going to ask you whether or not the equation is growth or decay, and then ask you to sketch the graph of it. So here's what you're going to be asked to do. First of all, when you look at the formula, it's going to be b to the x. And this formula is also going to be b to the x. And the reason why I use the letter b is the fact that when I'm looking at the letter b, it stands for base. Do you remember when we were dealing with exponents? We have the base is the big number, and then the exponents up and the up. That's why I use the letter b here. Okay? Now, I want you to notice that the equations are the same for both of them. It's what's inside the b is what matters. If the b is greater than 1, meaning what? What types of numbers are bigger than 1? 2, okay? Then it will be a growth. If that number is between 0 and 1,
It's less than.
it's decay. What types of numbers are less than 0 and 1?
Negative.
Or less than 1 but greater than 0? Decimals and fractions. But you need to be careful. Because what if I give you something like 9/4? That's bigger, right? Improper fractions are bigger, so they're still growth. It's whether or not they're proper fractions or decimals that are less than 1. So be careful with that for those to know which one's which. Now, here's how they look as far as graphing wise. For a growth, you guys just told me that we're going to go up. So for growth, what happens is I ride alongside the x-axis as close as possible, ever so slightly going up, and then I shoot to the moon. Okay? So it will rise gradually, and then once it hits a certain spot, it will just continue to climb and go up fast. Now, it never touches the x-axis. Even though it looks like it might on my picture, it never touches the x-axis. If that's the problem where you get something that never touches it, like it comes right up to it but never touches it, that's called an asymptote. Okay? It's kind of like this thing. If you've ever had a brother or sister and you go, I'm not touching you, I'm not touching you, I'm not touching you. Like, I'm not touching Delaney. Coming close, but I'm not. Okay? So therefore, it's kind of like that old thing, like if you have brothers or sisters that never did that to you. Okay? An asymptote is like that, where it'll come right up to you but not actually touch. The asymptote line is y equals 0. Unless we shift it up or down, left or right, which we haven't done that yet, and we will later, but not today.
Next one.
Decay. What'd you say the word decay meant?
Down.
To go down. Right. So now we're going to start up here and work our way down.
Hey, Bubba.
Almost like it flipped over this way.
Okay.
It is. I agree. Now, there is one point that I want to make sure that you guys are aware of on both of those graphs. That point goes right through here. What order pair is the orange dot on for both of them? The y-intercept, which is also what number specifically? 1. For every single one of those, it will go through 0, 1, unless we've shifted it, which we are not going to shift them at all today. That'll come later. Here's the reason why. What's anything to the 0 power? No. 1. Anything to the 0 power, no matter how big or how small, is always 1. So therefore, that's why the order pair of 0, 1 is on the board. Anything to the 0 power is always 1. Okay? Now, on your parts for 4 through 9 on your worksheet, it's going to ask you, is this growth or decay? And then sketch the graph. Okay? So here's what a problem would look like.
So is the other one y equals 0 then too?
Yes, they're both y equals 0.
Okay.
Until Annie, we shift it, and we're not going to do that today.
Just making sure.
Good question. Growth or decay? Decay. Why? It's less than 1. Now, can you put these in your graphing calculator to get the picture? If you wanted to?
Yeah.
Yeah. Y equals.
How do you put the X though? 'Cause isn't it?
Parentheses 1 divided by 3, close it, caret, and then to get the x. Does anybody know how to get the x?
Do you put the X?
There's x, t, theta, and n button.
I thought it was a 0.
That's a theta. Do you find it?
Yeah, I knew that, but I thought it's when you put the Y in there that it brings up the last number, isn't it? Or when, yeah.
So
I
this,
know how to do that.
okay,
It looks like that.
this particular graph will look something like this. If I'm not mistaken, it'll come downhill, correct? Because you said decay? Okay. Now, here's something else that I want to make sure I mention to you. I have the power of using different colors when I'm drawing like this. And some of you that have color screen calculators, you'll see that this thing goes down here and goes, almost looks like it goes right on top of the x-axis, right? And goes on forever. It's because they are so close that it looks like it's on top of it. Now, if you've got an older calculator, okay? Cameron, I know yours is an older one right there. Yours is in color screen. It looks like it stops right here, doesn't it? On the color on the black and white ones, it looks like it stops at about 2 or 3 and then doesn't go on anymore after that. It really does. It looks so much like the x-axis that it looks like it goes right on top of it. So if you're using your graphing calculator to graph it, just be careful not to stop it. It needs to go on forever. Okay? Do you want to do another one like this? Y equals,
I thought it's F.
could be y equals, doesn't matter. Hey, growth or decay?
Growth.
Growth.
Is it because it's bigger on the top?
It's because it's bigger on the top. Exactly. If I were to take 15 divided by 8, I would get 1.9.
Yeah.
Is that higher than 1?
Oh, so you can always check by finger.
Yes, absolutely. So this should be growth. Huh?
Why do you have to put it in like fractions?
They're not always going to be fractions. I'm giving you hard ones. Some of them are going to be something as simple like this, Makasia, where it'll be like y equals 5 to the x. Is that growth or decay? Yeah. I'm giving you hard ones to do this because if you can handle those, you can handle the one on the right for sure. So which way should it go? Uphill or downhill? Uphill, good. So it should look something like that. How you guys doing? Okay? All right, last thing I'm going to give you. There are no, take that back. There's 2 problems. I almost forgot about those. 2 of the questions are going to do this for you. It's going to give you a picture. It's going to say -1 and 1/3, 0 and 1, 1 and 3. And it's not going to say anything except for come up with the equation. That's what it wants you to do. I want to know what the equation would be in order to get these points. So here's what you're going to do. I would not, if I were you, I would not look at the 0 and the 1. Because remember, what's anything to the 0 power? 1. So this one, don't use that one. So now you have an option. You have to use either the ordered pair of -1 and 1/3 or 1 and 3. I want you guys to decide for me. Which one should I use?
1 and 3.
Okay, I would use that one too. If I could stay away from the fractions and negatives, I would if possible. So 1 and 3. The equation is y equals b to the x. And with the ordered pair that you're wanting me to use, remember, ordered pairs are x and y, are they not? So with the equation that I want y equals m, or b to the m, or b to the x, and I have an x and a y. What's the only letter I don't know? B. Right. I got to find the b. So let's plug in what I know. What number is the y coordinate you're going to use? Equals. You don't know b.
B 1.
And what's the x? 1. Bingo. So here's what it's asking you. What number to the first power equals 3?
3.
Yes. So b equals 3. So my answer is y equals 3 to the x.
That was easy.
Yes, it is. You'll have 2 questions like that. Then the last question that you'll have is kind of a word problem, but because we can apply them to a lot of different things. The 2 formulas that I'm going to give you now, you're only going to use one of them, not both of them at the same time. You have to decide which one you need to use. I know you can decide wisely. So now, looking at the 2 formulas I gave you,
Have we done
without, nope, not for me. For this particular thing, one of them is growth and one of them is decay. Which one do you think is growth?
The 1 plus.
The plus. This is growth. Which one's the decay? The other one, the minus, right? Good job. Now, to tell you what all these pieces are, the A stands for the initial amount. So when they talk about things like the initial the population in Minot in the year 2000 was 30,000 people, 30,000 would go in for the A. What's the R stand for?
Rate.
Rate. Meaning typically it's in percentage form. Like what they said, something like the population grows at a rate of 10% a year. 10% would be the R. And what do you think T is? Time. Now, what I'm going to give you is I'm going to give you a scenario right now, and you're going to answer questions based off of it. So you're going to have to figure out if it's growth or decay, how much the initial was, all that kind of, that's what you're going to have to figure out. Okay? So here goes the scenario. Ready? All right. The value of a car, Y, in thousands of dollars, can be approximated by the model Y equals 25.85 to the T, where T is the number of years since the car was new. So that's my equation. Part A. Growth or decay? Is it growth or decay?
It's decay.
Why?
0.85. It's too far.
Okay. Here it is, right here. What did I tell you about growth or decay? If it's above 1, it's
It's
growth. If it's between 0 and 1, it's
decay.
decay. The 25 doesn't do it. That's initial amount. This right here that's raised to the power, that's what matters. So for the 0.85, the 0.85 is between 0 and 1, it's decay. Have you ever heard of depreciation values on vehicles?
Yes.
How cars depreciate the more you drive them, everything else? That's what this formula is dealing with. Part B. What is the initial amount of the vehicle? 25 what? 1,000. Because it does say that it's 25, it's in thousands. So the initial amount is $25,000. Where did you get that from, Tyler?
Y is in thousands.
Y is in thousands, but where did you get the 25 from?
Oh, outside the parentheses.
Yeah, outside in the A spot, right? Now, here comes something that I didn't do. I did third hour differently than I did fifth hour, and I liked it fifth hour way better. Now, what they're going to want to know is they're going to want to know the percent increase or decrease. I want to know how much percent increase or decrease it was. So here's a way to figure this out. For percent increasing and decreasing, what I want you to do is take the 80 or 0.85 and make it a percentage. What's 0.85 as a percent? 85%. Good. The baseline would be 100%. If I had the vehicle exactly the way it was when it first was at the showroom, it'd be worth 100% of that. Now it's worth 85% of it. So how much goes down each year? If the baseline's 100%, and it's now worth 85% each year, it goes down how many percent? 15. What's 100 minus 85? 15. That's how you get it. Now, if it would have been growth, for instance, if the percent would have been, let's say that it would have been like, move the decimal over and it would have been 110. What's the percent increase then? 10%. Because it's above 100 by 10%. Okay? And the last thing that you're going to have to do is it's going to say predict or figure out how many years it takes for the car to depreciate down to 8,000. So now here's what you can do for that. You can do one of two things. You can do A, start plugging in numbers for T and seeing what comes out. It should start getting lower. And then you can figure out about how many years it is. Or B, you can use your calculator. Some of you last week, a lot of you actually last week, because only one person in here exempted it, took a test where you had to then, or you could have, did y1 is this, y2 is that, and find the intersection, right? If it says for part D, find out how many years it takes for the car to be 8,000, then 8 goes in for y. I put this into y1, this into y2, and I use the intersection feature on my calculator, and I see where they cross.
Wait, so what?
So 8 goes into y1.
How do you get put T?
T is the same as x when it comes to that map.
Is this like part D?
Yep, this is part D. I just can't fit it on the bottom of the screen. So part D would be figure out how many years it would take for it to equal 8,000 years about. $8,000. Sorry, I said the wrong thing. And again, when you get that,
I got a line.
Wait, how do we plug this in?
So 8.
it should be point.
Yeah.
And you can just put X.
Yep. When you just use
Is that
X.
all in the same thing because we all mean the same thing?
Mhm.
And then graph?
And graph.
No, it needs to be an exponent.
And you'll see the two lines hit. And I'm looking over Delaney's shoulder, and it's just really up in the upper right-hand corner. And if I go second trace again, option 5, enter, enter, enter. About how many years?
7.
About 7 years it takes for us to get that car down to worth $8,000. That's what you're going to have to do on the last problem.
What?
Okay? So, that being said, I'm going to hand them out.